Hi, everyone. Welcome. Thanks for staying with us to the end of the day. This is Converting Blueprints the Right Way. Today we're going to show our approach that we took to make our own conversion tool for nativizing blueprints. We'll share a link at the end for more info. But basically, we're going to try and make this as entertaining as possible because this is basically the cup holders of game development. Like, no one wants to deal with this, but when they're bad, it's really bad. So let's find out who we are real quick.
Hey folks, I'm Eugene Chukarov. I am a senior SD rendering specialist at Amazon Games and currently working on an unannounced UE5 project.
That's right. I'm Anthony Vaughn, lead tools engineer at Toys for Bob, and we also are working on an unannounced Unreal Engine 5 project. So let's break down the problem, like why we're here at the best talk at Unreal Fest. So here you have the problem, right? Your humble data-only BP, right? Starts out, innocently enough, and oh look, you add some variables and some functions, adorable. And then all of a sudden, it's bam, spaghetti-geddon, right? It's go time and you're hosed. You need a savior. You know who to call, but okay, maybe not him exactly, but you need something strongly related to him, right? C++ or Verse, and we'll get into options in a second. So let's break it down. So the problem we're talking about today is not a novel one, okay? All teams, big and small, deal with this, okay, at some point.
Now, scripters, they need to be nimble. And engineers, they need it to be performant. So perf isn't done until it's absolutely needed.
That's right. And everyone thinks, that's just the way it is. It's just, blueprint's going to blueprint, right? Hooey. We're sick of it. We're decided to take a stand, and we're sharing our plan with you guys. So let's dig in a little bit further.
Now, before we do, who here has had to convert blueprints for performance reasons?
Show of hands, show of hands. Wow. All right, so we're going to go with 99.9%, okay? All right.
How about complexity reasons?
Okay. A little less, 75% maybe?
How about just to refactor it?
Okay, the entire audience. All right. Well, you're in the right spot. All right. So again, your BP has become too slow or too complex to manage, right? You've hit big O of MG time, right? It's tough. So it's time to convert them.
Now, BPs are exclusive checkout, and you are using source control, right? Because if you're not, there's a door.
Ooh, it's harsh.
No,
harsh.
Hard references are everywhere. It takes lots of time to find them.
That's right. And you can't block scripters for any meaningful amount of time during this process.
And you can't move it on to C++, because then engineers will become a huge bottleneck.
That's right. Then scripters revolt, and producers will freak out from the burn rate.
So what type of conversion do we need? Well, let's talk engineers. They need time to get to it when they can, and as little time pressure as possible when they do.
That's right. Designers, again, like I said before, they can't be locked out of their BPs, okay? And not only do they need to be able to stay working in their BPs, they need to be able to extend and refactor them along the way during conversion.
Exactly. As for QA, well, they shouldn't be able to tell the difference that any implementation change ever occurred.
That's right.
So what are the steps that we're after? So here's a typical BP on a typical UE project. Right?
Sure. Let's just say yes.
So Eng needs to come in. They need to lock a ton of assets, including BPs, maps, sometimes INI files.
And design is blocked now, right?
And Eng is stuck for a long time doing something they don't even want to be doing in the first place.
That's right. And we're talking days to months, which does sound dramatic, but that's not a joke. Like BP conversion, depending on even a minor complexity, which we're going to demo to you in a second, gets long and fast. It's rough.
Yeah, and meanwhile, the team keeps moving and adding more BPs to the pile.
That's right. Missing out on the Playbox Switch 3000 launch, and now your producer has now gone fully into the red. They're burned down charting everything to the ground.
So, all right, let's break down what we need to convert. And it's basically these three assets. Right, your enums, structs, and blueprints. For enums, pretty easy. Create a C++ type, make sure it has the same amount of enumerators, and you're good to go. For structs, it goes up a notch. Same thing, C++ type, but now we also need to do a depth-first replacement because of all the dependencies. And for blueprints, even worse.
Yeah, it's the same, but worse. Yeah.
And you might be thinking, no duh, Captain Obvious. you might really be thinking, what about redirects? Well, we constantly get asked, why not use them? And it's legit. But redirects only work in 3 situations. Native to native, which is what they're designed for.
Yep.
Enum replacement, and wholesale BP class replacement. And that's it. For anything outside of those cases, you cannot use them. They will not work.
That's right. So at this point, we saw the road ahead of us. We took a step back and we thought about like, sweet baby Jesus, is there anybody else who's made a tool for this already? We don't want to do this. And so here's what we found, okay? UE, they had a built-in nativization that tried to do too much behind the scenes, though. They went all the way down to the node level. It's not something we were interested in. Plus, anyway, it went end of life in 427, so it's not even an option even if we wanted it to be. UE's header tool is great, but that isn't meant for compilation. In fact, it can give you emit illegal C++ code. But again, it's not meant for that. It's just meant to give you a general idea of what your BP might look like. Other solutions, many solutions, abandon BP altogether. But this is the lingua franca of UE. We didn't want to abandon that, so didn't want to deal with custom languages. Many more required a modified engine. Now, listen, you're already in Epic's release cycle, your own team's release cycle. When you've inevitably modified the engine when you're getting close to ship, the last thing you want is another thing to try and coordinate. It's just too complex, too many options. And then we even tried to throw large language models at it. Large language models, obviously the name of the game at the show, and they are coming along extremely well. This is still a little too much of a nuanced process and too customizable. It's too bespoke for each team. It became a manual process with even more steps. So it was just compounding the problem, not helping it. And none of them did the hard parts. And that's what we're here talking about today. Reference fix-up, post-processing, all that jazz. So you need a tool. That's again, why we're here, and we want to share a lot of pitfalls that we found. No one else is providing a good automated solution.
So before we set a few requirements for ourselves. First one is that we want a single senior engineer for about an hour. The project must stay in a runnable state throughout, and all assets and the references must be updated. That includes all maps, all BPs, and all the INI files. Source control should also be automatically updated, and everyone should be back to doing what they want to do. Engineering is code, design is scripting, and BPs can be converted repeatedly, all with no engine modifications, resulting in big cost savings and morale improvements. Producers are happy, we're happy.
That's right. That's right. So we're going to do the best idea pot.
One more slide.
Oh, we got one more slide? Oh, yeah.
All right.
Oh, yeah.
Time. Let's check it out.
Demo time. We're going to be doing the unthinkable and demoing live. Nothing is going to go wrong. So let's switch over to the old laptop. Yeah, for doing pretty awesome. All right. In our fictional dev team, we decided that our designers thought the Lyra project just wasn't cool enough, and they needed doors. You know what? Doors would make a game. Now, the reason why we also chose this is because we were able to make a full BP door system that's purely in BP. So let's just say they're like, engineers, don't worry, sit back, we got this. We're doing a full BP situation for you. The doors are very, very complex. So let's just take a quick peek.
And Anthony, I'd like a high score on this one.
Yeah. I don't want to detract with my awesome FPS skills or third-person skills, so I'm just going to show the doors in action. But yeah, so there you go. Doors in Lyra, who knew? And again, we'll show you an example in a second, but they did a pretty big system with this, right? So let's show the graph. Let's show the BP first.
Check out the BP first. Yeah. So let's start from the top right? It's an actor parent class, as you would expect. On the left here, all the components that make up this door. And if we go to the viewport, surprise, surprise, it's a door. If we look on the left side there, these are all the functions our designers put together to make sure our doors function the way they should. And if we go to the event graph, they also created a few component-bound events to handle overlaps for player collision.
Yeah, not half bad.
Pretty basic.
Pretty basic. So I'll bring up the graph, right?
That's it.
So we called our tool for this demo the Convertomatic.
Trademark?
Yeah.
Not really.
No one has ever thought of that name before. It is great.
Now, you might be looking at this and you're thinking, that looks a lot like the reference viewer. Sort of. if we look at the reference here, this has a lot more stuff in it. The reason is that because it shows you every asset it's referencing and every asset that's referencing.
Right.
All we care about is what types does our class depend on in code. So we grab up all of those and bring them over during the conversion process as well. So now Anthony, all he has to do is select them all, pick a folder, and we have a very convenient doors folder, and hit convert.
So practiced. So this is going to take a second. So we're going to talk to you about the 7 discrete steps that this is going through, right? So first of all, you're rounding up all your references. Everything, when we right-click that BP door, what does it reference and what does it contain? Those are the types that you're seeing in the graph, so dependency gathering. Then build your context data for each of those. You're going to have to rebuild them and reconstruct them natively, so you need that. Then you're going to emit C++. In our case, you could be emitting something else. We'll talk about that in a second too. And then compile so that Kismet and the reflection system are now aware of your new types. Then for BPs, you're reparenting. We'll talk about why not replace, and we'll talk about that in a second too. For some data types, you're going to do a wholesale replacement, which is going to feel good, cleansing. And then we're going to do the real tough nut, which is post-processing, like we mentioned, reference updates.
This makes sure this gets rid of hard references everywhere. It also makes sure to preserve all your default values and the values that you set within the level instances as well.
Yep, that's right. And it's that's the hard part. That's why we're talking to you today. Again, people get so focused on a very small part of this, and honestly, this is the gnarly stuff. All right, it succeeded.
Imagine that really happened.
Now we can walk you through what each of these sections mean.
All right, let's take a look at this first section. So this, as it says there, are all the types, the blueprints that were converted to C++, and then reparented to their new parent class, as you can see right there. We also show you what the new C++ parent is. And then in the next section, these are all of the assets and levels that used to reference the blueprints that you just saw in the previous section that now point directly to their newly converted types in C++.
Right.
So removing all hard references to those types.
Honestly, do it now. We've all been there. We all live when those hard references get made. BPs get duped, and your project loads slowly and more slowly all the time.
Absolutely. And in this section, well, this is everything you can delete right now.
Yeah.
And in your tool, you can add a button here to delete these right away if you trust your designers. We recommend doing it manually. Just be safe.
Yeah, exactly. We tend to not do destructive stuff in tooling unless really possible, but hey, at least now you know it. You have the option. Okay, should we fire up the BP and check it out?
Let's make sure the game still runs exactly as it did before.
Oh, yeah. Valid point. Valid point. This is why there's 2 of us on this project, and not just one.
I think you're inside a wall, Anthony.
Oh yeah, I forgot about this.
I like to do that. Let me. I am. Sorry, guys. Please hold.
So our backup also had a glitch. This is live development, folks.
We're doing great.
Yeah.
All right. Bam. Much better. All right. There's our doors from the first half of the demo. Do they work? They work. Oh,
Hey.
yeah. So again, that's proof is in the pudding, so to speak.
Awesome.
All right. So now we can look at the BP once again.
And like before, let's check out the parent class in the top right. Look at that. Now, it's the native base door class that we emitted into code. And if you look at the left side where all the components are, these are all now C++ components. And if we look at the viewport, exactly as you would expect, all of the defaults were preserved. This is still a door.
Hooray!
Now, if you look at the functions, you'll notice they now all have a suffix of _deprecated. The reason this is, A, this signals to designers that these functions should no longer be used directly and that they are being moved to C++, but B, this allows us to preserve functionality while engineering puts in the new implementation in C++.
Right.
And I'll show you the details of that in a moment.
Yeah, that's a critical requirement that we highly recommend you adhere to.
Absolutely. Same thing with these events here that are component bounded edits. As you can see, they are suffixed with underscore deprecated and do the exact same thing under the hood. And then Anthony, if you don't mind searching for interact,
Oh yeah, that's right.
we'll highlight a really cool thing. So check out this cast. This used to cast to W underscore interact. This now casts to the interact C++ parent class instead. And Anthony, if you click that little set node right there,
Yeah.
you'll notice this variable type as well is now using the C++ type, which is a little hidden if you expand that detail spread just a little bit.
Yeah. Sorry.
Perfect. You see that is the C++ version of this class.
Yeah.
We should have recorded the whole
Yep.
thing.
Key. And again, we're going to go in a much deeper dive on the benefits you get with CAS and what you're able to do now at this very moment that the native and BP are in perfect sync. All right, let's check out the code. What do you say?
Let's do it.
All right. So what do you say we do let's do an enum that's kind of simple for
Door security should be a good one.
Yeah, perfect.
Nice.
Ah, damn.
I guess we forgot to fill out our copyright.
My bad.
That's where your copyright would go.
Yeah, that's my fault. I will do that. I promise I will do that.
After that, it's your header boilerplate, right? Prime on ones. Any includes, in this case, we do core minimal as well to be safe. You can omit that if you like for enums. For the enum itself, as you can see, again, uenum blueprint type, as you would expect. But then you'll notice there's a meta tag that is custom to our tool. You should have one that's custom to your tool, and we'll go over why that's important in a moment. And then, if you notice, all of these have comments. These used to be tooltips on each of the enumerators in the user-defined enum. We bring those over as comments above each one, so this way, you get them in the IDE, as well as inside of UE, just like you did before.
Yeah.
And Anthony, do you mind speaking about the display name?
Yeah, so in this, remember, critical core pillar of your tool should be to keep designers working in BPs as if, just as they were before this conversion started. One of that is is maintaining their display names. They named something key/item. You'll also see question marks a lot in variables. We've seen it all. Obviously, those aren't valid C++ names, so we use display name to keep that translation for BP, and then give it a C++ safe name for ourselves. Yep. Let's crank it up a notch with struct.
Door safe.
Door safe.
Yeah.
Yeah, that's the one.
So to start with, same as enum, nothing changed here. But now we have a ustruct, again, a lovely meta tag that we added ourselves.
Yeah.
And if we go down, you can take a look at our properties now. Oh, again, tooltips added as comments. Your standard U property, edit anywhere blueprint read write for ustruct properties. These will be different per blueprints depending on what the options were set by the designer. So we do respect those.
Yep.
And if you notice, every field has a safe default that it initializes to, following UE's spec for ustructs.
Yeah. And you'll notice too that as Eugene touched on, very rarely do we just assume certain property specifiers or class specifiers need to be there, only unless it's extremely obvious. You have all this reflection data. It's right there. Just use it and just copy it over. It's not that bad.
Yep,
all right.
absolutely.
Now, obviously, the most complex thing is BP class, and it's not a replacement. Now it's a derivation. Let's talk about that.
Yep, that's right. So this one has a lot more includes to begin with, right? So these are all the types that it uses directly in this header. And if you look, we alphabetize them right out of the bat. You should do so as well, please.
Yeah, exactly.
We also do forward declares as opposed to including these headers. It's going to help with the compilation time, and frankly, it's the better way to do this anyway. And as before, we have our tooltip on top, the meta tag as you would expect. We do default to using blueprint type and blueprintable for our actors or UObject classes. The reason that's the case is because it's easier to be explicit and redundant here than parsing a actor or any of your base class chains and trying to figure this out.
Keyword being chains. It's too much of a
Exactly.
headache. Just safe.
That's right. So now if you look at these functions here, This is what used to be in your blueprints, and they were getting called directly. Now, all of your blueprints are calling these, and these, for the time being, are routing back to your blueprint logic.
Yeah.
And we'll look at that in just a second. And again, as Anthony noted previously, check out that display name. Is locked, question mark? Obviously can't
Is
have
locked?
that, so, but we do want to have a consistent designer experience.
I'm Ron Burgundy? Yeah, exactly. So that's right. That consistent design experience is critical. Let's check out the components.
That's a lot of stuff that got converted.
It is. It's a ton. And Eugene's talked about this already, but again, it's all of this stuff is in the metadata. Respect it and carry it over.
Yes.
Right?
Yes. Our components. You can see right now they are simply just declarations of those components. We'll take a look at the construction of them in just a moment. And then, Anthony, if you scroll down a little more, here's some view properties. And you'll notice that not only do we preserve the edit and blueprint read-write options that were selected, we also check if they are replicated. Do they have an on-rep, which this one does? Check that out.
Yeah.
We set that connection up as well. And we also preserve the defaults that were set in the blueprint,
Right.
as you can see.
Yeah.
This way,
Yeah.
when you create child blueprints, you get a consistent experience from this base class.
That's right. And again, this isn't the quality of life stuff. This, like this, you have to support this.
Yes.
You're making a multiplayer game, especially, well, you're dead in the water without it.
Absolutely.
I think that's it for the header file.
Yep.
Yeah, let's check out ye old CPP.
So here you can see we have the rest of our includes. Now, we are making the assumption here that you will be using these includes because it's a safe assumption. In your tool, if you would like to have your engineers add these as they need, by all means, you can do that.
Yep. Yep.
In the constructor here, you'll notice we recreate the entire component hierarchy as it was in blueprints, including any attachments and sockets and offsets that they had within your blueprint.
That's right. And we also, again, it's kind of a small point, but it's a critical one. Where there's a constant declaration for a certain type, use it. One of our kind of, I don't know, thorns in our sides or requirements, lowercase r, was this stuff should look like what a human would write, what an engineer would want to write. And it should also respect your team's coding standards. We come from places where, yeah, if you have an identity quaternion constant, then use it. Don't emit the equivalent as the unrolled version. Same thing with one vector. If it is a one vector, use the constant available to you.
Yeah, and to add to that point that Anthony just said, of outputting code that an engineer would write, that was a tenet for our tool here. That was a very strong driving point for the way we built this tool. So if you look at also 55 and 56, you'll notice those component boundaries that we looked at just momentarily, we bind those directly in the constructor to the new C++ class functions. Because, well, why not? You can do that directly right here, right now.
Yep. So let's take a look at our favorite on begin overlap, good old interact
yes.
back.
So this is how we
This is
make
the cool
sure
part.
that your blueprint, while your project stays in a working state during the conversion process. What happens is all of the calls that used to go directly to your blueprint logic now are routed through the C++ function, which for now simply routes back to the deprecated blueprint logic that is still in your blueprint. And then when an engineer is ready, they can come in here, either add the new implementation right here if it's a one-to-one conversion, and then comment out the line below. Or if you say you want to do a re-architecture, you can simply use this as your source of truth for everything in your project and start re-architecting
That's right.
this class any way you want.
That's right. Anecdotally, we've heard consistently that a lot of, your lead engineers, your tech directors are like, well, obviously I'm not going to want necessarily, probably not a one-to-one carryover from this one-to-one function reimplementation. I've got a larger re-architecture going on. Fine, but you must keep your designers able to work when they can. So we've got at least, if nothing else, they're still working, which I think is more important to keep everyone unlocked and going. But also, you've got right here a very clear list and a very clear touch point of where to make your changes.
And also, the other super cool thing you can do with this tool is now you can also auto-generate CVARs to enable or to swap between the old deprecated blueprint logic and the new C++ implementation at will, allowing designers and QA to test for regressions and any behavior changes.
Yep.
Super easy, super quick.
Yep, exactly. Yeah, I should have said regression testing, but any testing you want. But yeah, that's the key. So this is sort of the flow state that you want to keep in yours. So with that in mind, I think that concludes the demo. And
Anthony, I just noticed it. Would you like to speak about that duplicate?
Oh yeah. Okay, line 167 and 169. This is interesting. So it's an edge case you're going to have to handle. Even though we said code emission isn't the hardest part of this, and it's not by far. Okay, we didn't. That's a little bit, but there are some edge cases and some theories things that you need to handle. One of them is variable shadowing. C++ is more strict than BP script, and so this has this shadowed. We detected that is loading shadowed a previous variable or function declaration. So we have a system in place which just does index duplicating. So they're guaranteed to be unique, and you can just sort of automate that. It's a pretty straightforward thing to automate, but you got to take care of it. And while I'm on the topic, remember, someone can name a variable in BP that's nothing but C++ illegal characters, 100%. So
evil.
Yeah. I'm not saying that's great, but you have to take into account for sure.
And just to quickly note as well, using display names, your designers will not see that at all. They will see the previous parameter name like they did before.
That's right. Because let's be honest, this process is talking about, you're trying to take power away from us or whatever. No, everything will be as it was before. Yep. Even gnarly, horribly named variables in BP. So, all right, that concludes our demo. Let's get back to it.
Let's do it.
Okay, so imagine that was us right now.
And before you go on, Anthony, real quick, I should have said this when the video was up, but if you're passing parameters such as f vectors or f transforms in blueprints, they default to doing a copy. What you can do is be smart about it and catch those, turn them into const refs right away.
Yeah.
But to keep the experience consistent for designers and blueprints, use the auto-create ref term to keep the default value pin exactly the way it was. Very useful.
Yeah, and when this video is posted, you can pause and see the auto-create ref term meta tag that we use in our output. But yeah, good call. So regardless of what your specific needs are, you should break your tool into 7 discrete parts, okay? So dependency scan this is, again, gather up everything that needs to be converted. Asset-specific context data, build that data model, right? Code builder, you have the context, you have everything you need to know to create a native class. Make that native class, or classes, frankly. And then do a code recompile. We're going to talk about a couple options there, but live code is your friend here. Post-process, the chunky, the reason we're here, really. Update all those references, fix all those cast nodes, go deep every pin upon pin upon pin. Reference updater, do the same thing for everybody else in the world that's looking at these things you just changed. And finally, restore pin links. And we'll talk about why we call that out as a separate step in a second.
All right, let's dive into dependency scan. So the goal of this phase is to, like I said in the demo, gather up every type we need to bring along with the type you want to put to C++. So let's use this asset as an example, as a starting point. First, we need to discover all the types that it references and all the types that reference it. And then you're going to want to rely on the UE's reflection system for this. Run through the uClass, uStruct, UEnum, you name it. Go through it.
It's everything. So let's start with user-defined enums. You're going to see a pattern here that enums are going to be the simplest problem case, right? They can't reference other types. So there you go. Basically calculate their class name and prefix, round them up, gather up any modules that depend on them and packages that depend on them, and round it up for source control.
With user-defined struct, complexity goes up a notch. These can grow significantly since struct variables can contain blueprint types as well as other struct types. And you also need to check, is it a row data struct for a data table? Use the asset registry.
Yeah, that's not in metadata.
No.
So BP interfaces, about the same complexity as structs, but for different reasons. Obviously, they have function parameters. So you can treat their function parameters as properties. You're going to have to write some code to handle U properties. Fun fact, parameters of functions are literally stored as U properties of U function data. So that's kind of nice.
Thank goodness.
Silver lining.
So blueprints, well, they're the culmination of the other two. The reason is because they contain all the possible elements we can convert, as you can see in the snapshot from the demo we just did. Now, off the bat, you can ignore the construction script. This is only for blueprints. And we'll come back to the functions and variables used within it in the later step in the process. Atom graphs, you can ignore those as well. They are meant to be put together in NMVPs, not code. And just like the construction script, we'll come back to the functions and variables in a later step.
That's right. So now we know what has to be converted. We've got all the information. Let's build that context data, okay? These are the elements you need to worry about. That's all you need to care about. Type info, variables, functions, events, event dispatchers, and components, right? Again, enums are the simplest. They only have type info. You can get everything you need from it. One kind of catch-all is UE stores enumerators as new enumerator 0, 1, 2, 3. You've probably seen this if you've ever emitted a BP before. That's safe and consistent, but it's ugly if a human were to write that. They wouldn't write that. So you can dip into the metadata, the type metadata, to get the pretty enumerator names and as well. And you can use it to ensure that you get a safe type name as well. Remember, BP allows C++ illegal characters. By the way, making sure type names and variable names and all this stuff are type safe is going to apply to everything that we're going to show next. So this is the last time we're going to mention it explicitly, but make sure that this is part of the lifeblood of this whole tool, frankly. Yep. Structs take it up a notch with variable support, right? For type info, they can be used as potentially used as data table structs, right? And again, as we mentioned, no type information will tell you that. The asset registry is your friend there, right? Variables, properties for structs is a much bigger topic. We're going to get to that in a second. Interfaces, again, same thing, but for different reasons because of their parameters, their parameter lists. They're also bigger topics, however, because of that. So we're going to get to them in a few slides as well.
And blueprints, they have all of them and then some.
And that's why you're talking about it.
Thanks, man. So let's talk about class specifiers, because they require a little bit of a special attention. You can add these right off the bat, like I said earlier, and you can capture the rest from the reflection data. Don't add deprecated. If you already marked a blueprint deprecated, you obviously don't want to immediately deprecate the parent class. Doesn't make sense.
Self-esteem issues, maybe, I don't know.
You should preserve the hidden categories. U-class specifier, very helpful to clean up the details panel. These often, the category and display names, they often show up in the metadata. You would never write that yourself. You put them directly on the U-class specifier. You probably need to move them over. For variables, let's start with what we can ignore. The generated default tuner component, if it exists, it'll show up as a U property. It'll get in the way. Just ignore it. For Uber graph frame properties, same thing. They have runtime and BP only. Widgets not marked as variables, they only live in the widget tree. Don't care. Sorry.
Feels good.
For never replicated variables, you need to grab the rep notify func name and obviously keep a mapping between the two, but you're going to have to do that in code afterwards.
That's right.
There's a lot to go into here, but you can check out the rest on our site. But quick note on this. This is a fantastic chance to convert hard refs into soft object pointers and soft class pointers right away as a batch. Quick, easy, just do it.
Yep. Everyone will love you when your levels load perfectly
Absolutely.
in the editor.
The goal with this one is we basically just need to capture the function signatures. For custom events, they simply live on that node. Just go in there. It'll be the U function that they generate. For component-bound events, you also need to store what components they belong to, obviously, for that mapping in the constructor. For function signatures, check the function entry node for this one. Now, for interface functions, if they have a return value, check the function entry node in the interface graph specifically.
Right.
And for those that don't have a return value, they'll be simply on the UQ2 node event itself. The parameter context data, just treat that as variables. Super simple.
Yeah.
For components, the hierarchy is critical.
Yeah.
So for this one first, check if the root is defined in VP or if one needs to be made. It can be defined in VP or natively.
Right.
Always replace default gene root. Honestly, makes your lives easier.
Yeah.
Now, after all of this, you're going to want to save your pin links on every asset that you're touching or updating, because Kismet constantly tries to rebuild pin links, which normally, great, thank you. But we're doing so much behind Kismet's back, we need to preserve them ourselves for a later step.
And we're going to talk about that in a second. So now we have everything we need to emit code, right? We keep the code building step discrete for a couple specific reasons, right? First off, it's easier to support multiple languages, right? So chances are you're going to be emitting C++, but you could do verse, no problem, or sweet protobuf, and that's something that Eugene and I are specifically pretty excited about looking at next with our own tool. It's just awesome. Anyway, one thing feels obvious speaking to a bunch of engineers, but allow engineers to group declarations at the file level, whatever your native language supports with that. It's gonna make sense. You know, obviously you're gonna have some enums that go with a certain class, or maybe you're gonna have all of your UMG widgets separated out in a UI folder. Just let them do it. Also, really though, this is a good chance for you to be a good C++ and Unreal Engine citizen, right? You have a chance to enforce your team's coding standards. There may be people on your team who have strong, I'm sure there are, opinions about those standards. Just put them in now, then you're done forever. It's awesome. And also this helps designers, a chance anyway, given the dialogue that you're gonna have to have with them about this, is you can help them become better scripters as well. So now now emitted, let's compile it, all right? So the context data is built, we're good to go, but none of it is loaded yet. All right, you've got two options here, right? One is our beloved live code. It's been around a long time. It's easy to trigger with a single API call. It compiles, you see pass fail right away. It's instantaneous nearly. And it's a faster workflow. You're never leaving the editor, and therefore you're never to save context state. The cons, technically, you can't be 100% sure that your data is fully owned, fully formed, I apologize. But we found this just isn't an issue. Really, it's more of a lowercase c con than anything else. And so I don't know, whatever. But option two, not that we're already giving you our opinion, is you can stop the process right there, exit the editor, save off state, and exit the editor, and then build again, straight from your IDE. That will guarantee you, literally according to Hoyle 100%, that your data is up to date. But, and it's also cool too, one other pro is because you had to serialize all that context and all that state data, you've got it sitting in a file somewhere, you can look at it, you can pick it apart however you like. But again, that's more code chances for bugs to write out data. That's a larger surface area for you to mess up. It's also not a trivial thing to undergo. You have to maintain state across editor instances. Your team, I'm sure they have some custom tooling already that will interfere with that. So really, just don't do it. We recommend live coding. It's mature, it's stable, it's great.
Yep. So now we're on to the post process. So we have our native types. They're created, they're loaded, array. Let's make the VPs aware of them and use them. Now remember, it's these 14 assets from that demo.
That we totally did live.
Definitely. Which in our conversion results is these two sections. For the enums and structs, we don't care about those. You can skip them during the post process. They get deleted. For blueprint classes and interfaces, this is where you need to focus. Well, now begins the hard part.
Yeah. This is where it gets scary. So there's two major sections to the post process, okay? Phase one is clean everything out, all right, from your BP data. Save off your BP and child blueprint class default objects, remove variables and event dispatches from the BP, same with implemented interfaces, same with the simple construction script nodes and components, okay? Also, a weird one, rename the component archetype instances. It's not obvious why you would do this, but basically we rename them. They need to be around for Kismet to actually do some updating for you, but they need to be renamed so they don't conflict during the reparent process to the native version. It's just something we found out that wasn't obvious. You're aware of it now too. And then finally, reparent the BP to its native type and reinitialize it.
Yep. And for this one, if you remember no other section from this presentation, please remember this one.
Yeah, this is the meat.
So for attachments on instances, components of instance actors still refer to BP components. That would normally fix itself up when we restart the editor, but we recommend doing this immediately because otherwise your actor components won't show up properly in the level. To do this, you need to back up the class override before conversion.
Yep.
And if it was originally a BP class that you converted as part of this conversion, restore it to that BP instead of the new native type.
Right.
Because the implementation details are still there. If it was originally something else that a user set it to, obviously restore it to that value.
That's right. And then finally, fix up functions and custom event nodes. You have to fix these up. F-member reference is your friend here. If you don't know it, you're going to know it really fast. Basically, for BP functions now need to implement the native deprecated version. Okay, so in BP, assign this to the native deprecated function. Excuse me, and you're going to call reconstruct node on that a lot.
And we mean a lot.
Yeah, yeah. We really got intimately familiar with that function. Clear out user-defined pins. Again, because now the native function has defined those, Kismet will pick them up.
Yep.
Delete custom event nodes. Fully recreate them. So replace them with the regular event node and point it to the deprecated native version, okay? Rebuild your delegate nodes. This is another thing, and these are all the checklists you have to do for those. So if it's an event dispatcher that was converted, that we converted in the process, or you converted, you can then bind it in the C++ constructor. We just showed you that in the video. So we make sure to do that in our tool. You should too. And in BP, we can simply delete the bind node. Again, it's still there, it's still fully accessible. It's just easier to manage for those who are going to have to refactor it. With custom event nodes, you simply connect the red wire to your bind node, yeah? But if that custom event was converted, then we instead need to bind the converted C++ function, right? And to do that, we create a create delegate node that points to the converted C++ function. This is the only one that has a graphic with it, because that's hard as hell to visualize. And then you pass that into the bind node, okay?
Now, for rebuilding the component bound events, these are very similar to custom events. You simply delete the component bound event, then replace it with the UK2 node event instead. But this now points to the deprecated version of the original BP event.
Right.
You definitely need to go through, this is the fun part actually, is replacing all the calls that were going to the blueprint functions with the native functions themselves. And again, F-member reference is where it's at. For this one as well, little tip, use UK2 node call function set from function. Can anyone say function again?
Yeah, exactly. It's a lot of functions. So for get set variable nodes, you're going to have to update the member reference info to the new native type, as you saw with in our example. And also, by the way, in the UK2 node function entry node, local variables live here as well. We got to go.
So we also need to fix up the archetype instances. So during reparenting, actor view properties that point to instance subobjects lose their values. In other words, a placed actor in a level with variables that refer to its own components get nulled out. For this, simply iterate over the archetype instances. Make sure you skip the CDO. It's for some reason included in that list. And one more. Yep. Assigning the subobject to the property it belongs to, pretty simple. Just keep a map beforehand and apply it after.
That's right.
And finally, the last step of post-processing, we update the TDO. So for this one, save off the property values, and then reparent, then restore those back. Your archetype instances, they'll get wiped as well. Make sure you keep track of those. And same thing for the child BP CDOs. Quick tip here, add blueprint editor utils, get children of blueprint helpful.
That's right. So now we're in the second to last step, similar to post-process, but we're updating all the referencers, right? There's some important call-outs here. So these are for everything in BP that reference the things you converted, right? Cast nodes just became super easy. Before they were hard references. Well, now you can cast them to the native type, which is free, safe, and you definitely want to use native parent, not the BP one. Now it's a simple pointer assignment. It's a soft reference. It's awesome. Use it.
Yep. Wildcard pins, well, they should be left to Kismet.
Yeah.
They're most commonly on macros, obviously. And for this one, there's so much type deduction that needs to happen. The easiest thing, just disconnect them all and reconnect them.
Yeah, ask us how we know. Stupid.
Yeah, just let Kismet do the work.
Yep. Okay, so now, so your enums require patch up. Early we showed you how UE stored those enums with the indexing values. Make sure you remember you kept your mapping that dog and cat equal new enumerators 0 and 1, obviously.
For data tables, so they need a little bit of a special handling. The native type is identical, take advantage of that fact. So simply export the data to CSV and then re-import it right back into the same assets, but this time with the native structs.
Yeah.
Done.
It's just easier that way. We tried the hard way, not great. So don't forget IRNI files, right? Basically, all you have to do is scan every class with the config flag set and check each property for a ref to a newly converted type. Honestly, we recommend stopping there for IRNI files. Let an engineer look at it from that point. You need to make decisions. It's not very straightforward to automate.
Yeah, it needs to be a conscious decision.
That's right. Now, basically, you're done. It's go time. All references are updated. Now it's time to do a Kismet compile, right? You will see some compilation errors here in Blueprint, but that's what this next step and the final step is all about fixing up.
All right, so this one, the conversion tool did a lot behind Kismet's back. So Kismet removed pins. It kept orphan pins. It maintained the valid connections. Not great. I get it. It's just trying to help. I know. But Epic, can we please have an option to turn this off? That's great.
We are a special case.
So for this, honestly, disconnect all the pins. A lot safer and easier that way. And then you can use the pin link data you saved when you put the context data to restore it back. Quick tip, combine split pins at save time. There's just less of a headache that way. And then split them again at restore time. Also, don't forget pins. They can have illegal C++ names. That bit us.
Yeah.
And so did this. They have default values. Make sure you restore those properly.
All right, so that's pretty much it. We're coming up on time, so we're going to blow past this. But now you press play, you test, validate, submit, and just like our demo that went perfectly live, so will yours. Scripters are back in BP. Engineers are fixing things in code. It's great. And your producers aren't going absolutely nuclear, which is awesome.
But there's some cool stuff you can do now as well.
Yeah.
So we are allowing designers to iterate during conversion. That was a requirement for us. Here's some tips to make that work. So build the context data only for the newly added blueprint types. Remember that tag? Use that to detect it.
Yep.
Post-process and reference updated don't change at all. The code building, you do need to figure out where to put the new code. Don't build a C++ parser. Keep it simple. And then, as if being able to reconvert infinitely wasn't awesome enough, you get a sort of a performance subclass factory as well.
Your designers might like this, yeah.
Yeah. So it's pretty straightforward. Let's say design made a BP enemy class, and then we converted it to a native class, A enemy. And they've reconverted it a bunch of times alongside engineers, thanks to your sick custom meta tag.
Sick. But then your creative director hired the best flying enemies designer on the planet, and you can tell by his hair. So they created the most awesome flying enemy, but started dumping it into the native class. So if you built your tool according to our steps, the conversion process will automatically reparent that to a new native class, maintaining the hierarchy, and then it's just a matter of duping the BP, switching it over, and starting fresh again. It's a huge knock-on thing we didn't even realize was going to happen.
Yep.
So,
and now we're thinking at the speed of thought.
yeah, we are.
Designers, they can use it.
Got to deliver. And critical delivers will be performing as well before the 11th hour, which is fantastic. And
production loves it because the team is working together earlier on.
That's our time. Thank you guys so much.